Hello friends, welcome to my channel. So after a long time I am making this video. So now I'm trying to making some question answer series for upcoming Tifr GS 2021 for chemical science only. So as per Tifr always trying to judge your application power on the fundamental concept. As per the name suggests, TIF, Tata Institute of Fundamental Research. So they always trying to judge your fundamental knowledge and your application power. So today I am going to discuss a problem from NMR spectroscopy. See, what's the problem? The problem says a scalar coupling, basically 2J coupling, constant for a doublet in compound X is measured at 5 Hz on a 500 MHz NMR spectrometer. Which of the following statements is incorrect? Read the question properly. At first, this is the first task. Which of the following statement is incorrect? The incorrect was is most important one. Incorrect. See, some basic things are required to clarify this option to choose the correct option. What is the basic thing? See, chemical shift. Chemical shift. As per you know, the chemical shift of NMR spectroscopy. The chemical shift, which is designated as delta, reported in two parameter, in two unit. One is ppm and then other one is Hertz. The ppm units that is independent, the ppm unit that is independent of instrument, but the Hertz unit that is dependent of instrument. Then spike position. Spike position. See, what is the spike position? The position of the peak. The position of the peak. See, this is a peak, this is a peak, this is a peak. So the position of the peak, this is the spike position. And what is the chemical shift? The chemical shift is, see, I think you have a triplet. So 1 is to 2 is to 1. The chemical shift is this one. The average position, this one, is the chemical shift. So the chemical shift is reported in two unit. One is ppm and another one is Hertz. The ppm units is independent of instrument. It doesn't matter if you use 250 megahertz NMR spectrometer or 500 megahertz NMR spectrometer. It doesn't depend on that. But the Hertz unit, when you report it in Hertz unit, that is dependent on the instrument. There is changes if you use 500 megahertz to 100 megahertz, then it changes. And the spike position, the position of the peak, the position of a particular peak, this one, see, this one or this one or this one, the position of the particular peak, that is also, that's this one also, in hertz or in ppm. You can write down in hertz unit or in ppm unit. These two are dependent of instrument. These two are dependent. Okay, sorry. These two are dependent on instrument. But the last one, as the question comes, coupling constant. All know, we all know what is coupling constant. Now, what is coupling constant? See, I guess this is a peak. So the gap between the two peak. So this is the coupling constant. See what happens. The coupling constant also reported in two units. One is Hertz and the another one is ppm. But here, see, at chemical shift in ppm unit, that is independent of instrument, but the Hertz unit, that is dependent of instrument. But here the reverse thing occurs. The Hertz unit, that is independent, of instrument, but in ppm unit, that is dependent on instrument. Dependent on instrument. See, what is the question options? The option says, see, here I mark the correct options at first. The question says the which of the following is incorrect. Which of the following statement is incorrect? So the second option is, for this doublet, the coupling constant measured in Hertz depends on the field strength of the spectrometer. But here I mentioned the coupling constant when reported in Hertz unit, that is independent of instrument. So this option is the incorrect one. So the option B is the correct option for this question. Thank you for watching, and please like, share and subscribe this channel.